Hello students, today we are going to look at this very interesting problem in probability. So let's have a look. A drunk mathematician called Euler is performing a random walk along the number line. His original position is x is equal to 0. He takes a step forward or backward with equal probability. His home is at x is equal to 3 and there's a pit at x is equal to -2. What is the probability that he'll reach home before falling into the pit? Give this question a thought, and when you're ready, play the video for the solution. So we've got Euler over here, and we've got his home at 3 and a pit at -2. Now, please understand the question first, the premise of the question. He could go one step forward or one step backward with equal probabilities. Now that means that from starting from x is equal to 0, is either moving to x is equal to 1 or x is equal to -1. And since these are equal probabilities, half for this one and half for the other one. Now let's define the question asked, and that is, let's define P as the probability for him reaching home before falling into the pit. And let's try and rephrase that. That is the probability of reaching x is equal to 3 before reaching x is equal to -2. That is the probability of moving a net of 3 units in this direction before moving a net of 2 units in that direction. That is P, our final probability that we have to find. Now analyze that there are infinite ways of reaching to x is equal to 3 before reaching x is equal to -2. He could go the direct way, x is equal to 1, then 2 and then 3, that is the direct way. Or he could go 1, 2 and then 1 and then 1, 2, 3. Or he could go 1, 2 and then 1, 0, -1, 0, 1, 2, 3. There are infinite ways possible, and mind you, when a math teacher says infinite, there are actually infinite ways possible. He could go from 0 to 1 back to 0, then 1, 0, 1, 0, infinite number of times. So how do you analyze such a question that has infinite elements in the sample space? The probability tree helps, but only if you use it judiciously. Let's see. Let's analyze each possibility over here. That's what the probability tree does. It chooses to analyze each possibility. Once the Euler reaches x is equal to 1, a very interesting thing happens. A symmetricity is achieved. The symmetricity is that now what we need to find is the probability of reaching 3 before reaching -2 from 1, which is exactly symmetric to the situation over here. Actually, it is right exactly the opposite. Over here, he needs to move 3 units in one direction before 2 units in this direction. Over here, he needs to move 2 units in this direction before moving 3 units in this one. Therefore, this situation is the complement of this situation. And what is the probability of a complementary event? It is 1 minus the probability of that event. Obviously, the probability of something not occurring is the complete probability minus the probability of that occurring. Therefore, if we had defined P as the probability for reaching home before falling, then 1 minus P would be reaching -2 before reaching 3. And the probability of reaching -2 before reaching 3 is the same as probability of reaching 3 before reaching -2 in this situation. Therefore, the probability of reaching x is equal to 3 before x is equal to minus 2 over here is going to be the complementary of our original probability, that is 1 minus p. Let's analyze the second situation. If it moves towards x is equal to minus 1, there are only two ways to go. And the first one, we do not want the first one because obviously he'll fall most probably to his death. That is moving to x is equal to minus 2. We don't want that one. The other one takes him back to x is equal to 0. And he starts all over again. The probability is same. Therefore, we get a recursive definition for p. And by recursive, we mean that to define p, to calculate p, we take the help of p. Now, according to the probability tree, the probability p is equal to half into 1 minus p, or always means plus in probability. He could go this way, half into p again, half into p again. Solving this equation, this recursive equation in p, we can find the value of p. Thus, there are 2 by 5 or 40% chances that he'll reach home before falling. Hello YouTubers, this is a new channel that we've set up about visualizing math with the minimalistic input so that we can concentrate more on giving you more information, having fun with mathematics rather than cutting and editing and putting in graphics and all that shit. So do like and subscribe and share if you like the video, and comment. I would love to hear from you.